Hey y'all, hopefully you just turned in your quiz. I hope you took your time, used those test-taking strategies I taught you yesterday, highlighted, annotated. Now that you've turned it in, you probably have a good amount of time left. Probably 15, 20 minutes, maybe just 10 minutes. Either way, you have a couple of choices here. This page is tonight's homework. I am currently updating your agenda. It says none, but that's not correct. This is tonight's homework. The good news is it's really just a quick, simple activity. So you have two choices. You can pause this video, try to do the whole thing, and then press play and see if you get it right. Or do it along with me. Whichever one you feel is going to work for you, just know when you come to class tomorrow, this is what we're going to check. Okay, so here we go. I'm going to call this activity because that's really what it is. However, since I'm not in the room, we can't all get up and do it together because some people around you are still taking their quiz. The activity is simply this. Match each equation to the correct graph, table, and context. There are a couple of typos, not many, but just a few typos in here. Here's the first one. This is math. It should say match. It's a matching activity. Match each equation. We have 6 equations. Match each equation to the correct graph, table, and context. That should really be or context. You will use each of these only once. Each of these equations matches either one of these two graphs, one of these two, if you flip it over, word problems, or one of these two tables. Here we go. Let's see how you did. If you did this on your own already, then you've already paused the video, you did it on your own, and now you're just checking to see if you got it right. If you didn't do it on your own, you're about to do it with me. Here we go. Each equation needs to be matched to one of these representations. To figure this out, I'm starting with the easiest. The most basic, easiest to read would be the graphs. Grab your yellow highlighter. To figure these graphs out, it's basically what you just did on your quiz. It's another test-taking strategy. I'm going to highlight this y-axis. Y-axis, not intercept, y-axis. And I'm going to look and see, okay, if I know that this has a y-intercept, because this is going to intersect this y-axis at some point, then I'm just going to find that y-intercept and label it. Here it is. It's been labeled as point B. I'm going to list its coordinates. The coordinates of this, I know the value of x is 0, and according to this y-axis, the value of y is positive 320. Stop and look. I notice, if I look over here, this is the only one that has a y-intercept of 320. So I know this is most likely going to have to be the equation that I use. But Miss Leonard could have made a mistake. There might be a typo. So let me double check this slope real quick to see if that's true. Use the points that are already there. Some of you messed up yesterday because you were trying to use points like this one. Don't use that point. You can't, you don't want to estimate what that value is. Use points like this, or points from here to here. Use the points that are what I call pretty points. All right, I want to calculate the slope. I can do the rise over run. Rise over run. This is not a rise of 1. This is not a rise of -1. From A to C, it is going down. Look at your scale. This is 220. This is 200. That means minus 20. Pay attention to your scale, okay? Look at this. My run. This is going from 20 to 24, which means my run would have to be 4. Rise over run. That means I'm going from -20 over 24. So my slope, M, is -20 over 4. Well, I don't see that. But I know if I simplify, a negative divided by a positive equals a negative. 20 divided by 4 is 5. My slope is -5. It matches. Congratulations, you've made your first match. Now, if that boosted your confidence a bit and you want to pause this video and try to do them on your own, go for it. Pause it and try to do them on your own. Otherwise, let's keep going. Next, I need to find the equation that matches this graph. Do the same thing again. Highlight that y-axis. Not y-intercept, but y-axis. find the y-intercept and label it. I can clearly see that my y-intercept is way down here. When x is 0, y is positive 2. That tells me my y-intercept would have to be plus 2. Look at your options. I only see 1. Let me make sure that's right, though. According to this, don't tell me this doesn't have a slope. It does have a coefficient, which is my slope. The coefficient in this case would be a 1. So this better have a slope of 1. Check this out. I better be able to go up 1 over 1, up 1 over 1. And every single time I do that, I better land on a pretty point. Well, let's see. Up 1 over 1. Oh, look, it's another pretty point. Up 1 over 1. Oh, it's another one. Each time I go up and over, I land on the line, which means this does have a slope of, think about it, positive 1 or negative 1. From left to right, it is increasing, so positive 1, which matches that equation. 2 down. Fill in what we've just discovered. I just discovered that this equation would have to look like y equals my slope, negative 5, x, I have my coefficient, plus my constant, according to this, my y-intercept is 320. I don't know why I tried to squeeze that in, sorry. Okay, over here, I know that y equals my coefficient is my slope. Slope is 1, so I don't need to write it. Coefficient means it has the variable, plus my constant, in this case, that was a positive 2. How are these graphs different? Good. You should have said something like, this one has a negative slope, it's decreasing left to right. This one has a positive slope, it's increasing left to right. Analyze the point where each graph crosses the y-axis. How can you tell this point? By looking just at the equation. In other words, look right here. How could you have found that? Just by looking at the equation. Box that part of the equation. I'm so sorry I wrote this so small and squeezed it in. Put a box around that y-intercept, just like we did yesterday. Same thing over here. I see my y-intercept is a positive 2. I look at my equation, I see there's a positive 2 as my constant, which means I could easily see my y-intercept. Last question, what is the rate of change for each graph? Circle the part of the equation that shows that rate of change. I'm trying to help you see the connection between graphs and equations. Graphs and equations. In this graph, I can see down 20 over 4, down 20 over 4. That also means down 5 over 1, because this has a slope of negative 5 over 1. So if I look at my equation, I should be able to circle a negative 5, and I can. If I look at my equation here, I should be able to circle a 1. This says I go up 1 over 1, up 1 over 1, up 4 over 4, up 5 over 5. Any equivalent ratio. That's why I can circle a 1 as my coefficient. Good, flip it over. 2 down, 4 to go. There's a typo in this word problem. I believe it's this word problem. Yeah, there's a typo. Let's get rid of this final statement down here at the bottom. So pretend book has a period after it. All right, read that word problem very quickly to yourself. Okay, let's mark this text. Let's figure out which equation this would match. Challenge yourself. Try not to even look over here, because you know you're not going to have a word bank most of the time. See if you can write an equation just from this word problem. Y'all have been doing that all week, and you've been doing a great job. Try it on this one, and then we'll do the same thing to the next one. But for now, let's just look at this one. All right, here we go. Michelle read the first 40 pages of a mystery novel before she fell asleep. 40 pages. First 40 pages. That sounds like either an initial amount or a rate per something. You should know which. The next day, she read 1 page every 2 minutes. 1 page every 2 minutes. That sounds like something, either an initial amount or a rate per something. Hopefully you figured it out. You're exactly right. The equation would be y equals something x plus something. I need a slope, rate of change, and a y-intercept, constant, initial amount. Well, initially, she read 40 pages. Look how I said that. Initially, she already had 40 pages read. Then, every 2 minutes, she read 1 page. That's 1 page every 2 minutes. So then, how much did she read every 1 minute? We want this to be a unit rate. If she read 1 page every 2 minutes, that means in 1 minute she read half of a page. Flip this over and you'll see the equation that matches this is right here. 1/2 x plus 40. Check. 3 down, 3 to go. Next, Bella's Pizza Shop. Read this word problem silently to yourself. Ooh, that's a lot of information. I got to find an initial amount. I need to find a rate. Let's start breaking this down. First of all, go all the way to what they're asking me about. Bruce ordered a large pizza with 3 toppings. Here's what Bruce actually did. Large pizza, 3 toppings, which means who cares about $4.50 for a small pizza? No one cares. $7 for a medium pizza. No one cares. We do care about $9 for a large pizza. Additional toppings, well, that sounds important because it looks like, hey, he ordered 3 additional toppings. So I guess we should probably pay attention to that too. Additional toppings cost extra depending on the size. So here we go. Bruce orders a large pizza. He's got to pay $9 for that. He's going to pay $9 for each of something? No, that's a one-time fee. $9, which means I know right away that's going to be my plus B. That's going to be my y-intercept, $9. I'm starting to slowly fill this equation in. Y equals mx plus b. I got to figure out this m thing, this rate. What am I paying per something? The toppings. Well, I got to work backwards on this one. He's buying 3 toppings. That's not a unit rate. I need to know how much 1 topping costs. Well, I got to work backwards. I don't know how much he paid for the 3 toppings. The only thing I do know is in total. That means all together. The pizza and the toppings cost $12.60. All right. So if the pizza and the toppings cost $12.60, if I want to figure out just the toppings, take the pizza out. Subtract 9. That'll leave me with $3.60. Here's how much he paid for the 3 toppings. Again, I need a unit rate. That's not a unit rate, but I can figure that out by simply dividing. $3.60 divided by 3 would give you $1.20. Check out what I'm about to say. Per topping. That is my slope. That's my rate. He's going to pay $1.20 per topping plus $9 for the pizza. There is my equation. Flip it over and you'll see it matches this one right here. Again, I want you doing these word problems without looking at this bank because you won't have that equation bank in normal situations. Good. Last but not least, grab that red pen. Let's label what the 40 was. The 40 was B, my y-intercept. Label what this was, M, my slope. The $9 was my y-intercept, B. And then somewhere in here, I had to work backwards to figure out $1.20 was M. It wasn't given to me. I had to work to get that. M was my slope, $1.20. All right, here we go. Let's write these equations without looking at that word bank. I'm sorry, I guess number bank you'd call it. I can see right away, hello, here is my y-intercept because the value of x is 0. So it's going to cross the y-axis, which means all I've got to do now, I already have something x plus something. I already have this part. There it is, 120. Now I just have to figure out my slope. Same thing we've already learned. Pick two y values, find the difference. That's going to be my rise. Use the same corresponding x values, find the difference. That's my run. Then write that as a ratio of rise over run. Find the coefficient. Here I go. Put that in your graphing calculator. Pick whichever two you want, but highlight them. I'm going with 320 and 264, which means I also got to choose 25 and 18 in that order. All right, alpha y equals 1. Put all that in together. 320 minus 264 is my numerator. Denominator, 25 minus 18. Notice I hit minus each time, this button. There were no negatives, so not once did I press that button. Hit enter, there's my slope, positive 8. There's my equation, flip it over and you'll see y equals 8x plus 120. Now yes, logic has already told you this is going to match that last one, but you won't have a word bank any other time. So let's flip that over and see how did we get that answer. Once again, yay, be super excited when they give you the y-intercept in a table. 0, 6. So I can write that equation with one of my parts already filled in. Something x plus something, the y-intercept, y equals mx plus b. The y-intercept is right there staring me in the face. B is 6. All I have to do is, once again, find the rate of change. Calculate the slope. My rate of change in this case, I can pick any values I want to prove a point. I'm not even going to make them close to each other. I'll choose those two, which means I got to go with the corresponding x values. I'm going to go in this order. 18 minus 9 is going to give me my rise. 16 minus 4 is going to give me my run. I really hope you can actually do this one in your head. Forget the graphing calculator. However, you're allowed to use one. So if you still would like to use that graphing calculator, I say go for it. To calculate my rise over run, I'm going to see 18 minus 9, which is 9, over 16 minus 4, which is 12. 9 over 12, you can simplify in your head. But hey, why not use the graphing calculator? 18 minus 9 over, sorry, not exponent, over, let me get rid of that exponent. Delete, sorry. Over 16 minus 4. Enter 3/4. This table has a slope of positive 3/4, which means, congratulations, you have matched your final table. 3/4 x plus 6. On the back, you calculated the rise of a run on your graphing calculator. How can this number that's added in each equation be determined from a table? It's highlighted, where the value of x is 0. If you did not finish this in class, then it is tonight's homework. I'm updating the agenda. You will finish this, and this is what we will check tomorrow when I come back. I'll see you tomorrow. Thank you for being respectful to your substitute who's in the room with you. Have a great day.